So this week we had two articles, and I'm going to be summarizing the So and Kim article. It was the longer one for you. It was learning about problem-based learning, student teachers integrating technology, pedagogy, and content knowledge. So it started out with some kind of general knowledge before talking about the study that they did. Um, and in general, there's just kind of a mismatch between technology tools, content representations, and pedagogical strategies among pre-service teachers, which is us. And then we talked a little bit about teacher education. So like the program we're in now would be a teacher education. And education programs are inadequately preparing pre-service teachers to integrate technology. It's not enough to just expose students to multiple technologies. We have to actually practice integrating them and find that balance of pedagogical and technological knowledge. And then TPACK we've talked about before. It's something that's really complex, it's all interrelated, and it's often taught in isolation. So successful technology integration is not simply adding a technology component to the lesson. We've talked about this a little bit. And technology integration is also really related to teacher beliefs about technology and kind of their experiences with technology and like what they've practiced in their classrooms and been exposed to, etc. Some ways to help develop TPACK. It's a long-term thing, so it's not just like one course learning about TPACK. It has to be integrated kind of into everything. And then we must be the practitioners of TPACK. It's not enough to just like learn about how to practice it. We actually have to practice it. And then the article also talked about kind of this disconnect between believing, knowing, and doing. So there's espoused PCK or TPACK, and that's kind of when you know about the thing and you can talk about it with your colleagues, but you're not actually using it. And then in use is when you have the knowledge and you're actually using it for teaching and learning. So the study they did kind of looked at pre-service teachers and their lesson planning, how they integrated technology into a problem-based learning lesson over their various content areas. And it studied their perceptions of TPACK and the difficulties they had applying TPACK in their lesson. The article had this really great Venn diagram, which we've seen before, looking at how interrelated TPACK is and the different types of knowledge. So yeah, you can see here it's really complicated and there's a lot that goes into it. It's all related. So the results of the study, the pre-service teachers, there was like a lack of understanding in three major areas. That was technology integration to better support problem-based learning, task design, and the teacher's role as the facilitator. There was also kind of technology as a delivery medium versus an instructional tool. So did the teachers just kind of give a lecture that was a PowerPoint versus did the students actually engage with technology and use that to better their cognitive understanding of the subject? Again, there were discrepancies between knowing and doing. They found the teachers clearly knew what problem-based learning was and they knew all the stuff, but then doing like TPACK and those pedagogical techniques, they knew about them, but they weren't doing them. So some difficult areas they had were generating problem statements, integrating ICT, which is like instructional technology basically, designing tasks to be done, and defining the roles of the teachers and learners. They also had difficulties selecting the appropriate tools. So there are like lots and lots and lots of instructional tools, and it can be hard to decide which one is most appropriate for your students in your lesson. They also had difficulties with scaffolding, so how much information do I provide students how much of it are they exploring and finding on their own. And then the biggest limitation identified by the pre-service teachers of both PBL and ICT was the time limitation. It takes a lot of time for these. So, and then the article kind of wrapped up by giving some suggestions for how pre-service teachers can achieve deeper connections in TPAC. So there's a design series of integrated models, provide situated practices for feedback and reflection. This I kind of thought of as like our practicum. And then present various examples of technology integrated lessons. So giving us that example of how we can be truly integrating technology instead of just having a technology component to our lessons. And just in general, holistic programs to form connections in TPAC are needed. And that was it.
So for my portion, I did the Jasper experiment. The article started out with an example of an eagle. Two kids are lost, and one of them finds an eagle, and they are trying to figure out the best way to get the injured eagle back to a animal hospital so that the eagle can be helped. So basically the Jasper experiment was a series of 4 problem-solving videos with a focus to see if technology could help anchor mathematic principles. Why this is beneficial: it increases student interest. It helps students who are struggling with reading, especially, the article mentioned, especially ELL students or SPED students. It encourages students to dig deeper into the problem because most students will have to go back to find more information about the problem. As many teachers, when they're showing the video, they don't tell the students they will be doing math problems, so students automatically have to go back and look and find more information to try and solve this real-world problem. It increases generative knowledge, generative knowledge is the ability to construct mathematical arguments, plan strategies, and solve problems. All the data needed is there, and it's consistent every time. There's no switching data, even though you'll get different solutions every time. The problems are complex and real-world examples, and then it connects to other areas. Like the eagle example would connect to geography and map reading and those types of things. The results: students who are participating in this program, they are better at solving multi-step problems. They are more positive about mathematics as a whole, seeing its usefulness, and they want more challenging problems because they see that it's useful. And the more that they do these problems, the more mathematically independent these students will be, meaning they need less and less teacher assistance to push them towards finding a goal. Based on everything that we've seen, we should definitely use more of these Jasper examples so we can extend research on these videos. And that's it.